Radioactive decay. So there are different types of radioactive decay. So the first is alpha decay. It's a type of radioactive decay when the nucleus emits an alpha particle. An alpha particle is the nucleus of an He atom. So usually it's written like this: alpha, 2 with 4 on the top, because that's the mass number, and 2 on the bottom. And so when we look at alpha particle decay, or we can look at this. Let's say uranium. It's going to undergo alpha decay. And here it's releasing the alpha particle. So this is the alpha particle, or He, usually written as He, atomic mass number 4, and the atomic number 2. So what we have here is we're left with, because we have taken away that, we have two less protons and 2 less neutrons, and both of them affect mass number. So we lose 4 from the mass number. So 34 is now our new mass number. But our atomic number only goes down by 2 because we lose protons, and that's affected by the atomic number is only affected by the number of protons. So to check to see if you've written this correctly, what you can do is add up the atomic numbers and see if you get 92. So 90 plus 2 does give you 92. And 4, you can add up the mass numbers. 4 plus 234 is going to get you 238. But don't be confused, because 2 protons and 2 neutrons are making the mass number 4. You only lose 2 neutrons, not 4 neutrons, but 2 neutrons, and then the other 2 that's part of the 4 comes from the protons. Now beta decay is a type of radioactive decay when a neutron is converted into a proton and a beta particle. And the beta particle is an electron E. So a neutron becomes a proton plus an electron. So a neutron is made up of both proton and an electron. So what we're going to see with this problem is, let's take CS. It's going to undergo beta decay. Notice that its atomic number goes up. Its proton, this mass number stays the same. The mass number stays the same, but the atomic number goes up because a proton is created. And so the proton is created, changing the identity of what it was. So now it becomes Ba. It becomes Ba instead of Cs. And now we have that electron that has been ejected from the nucleus because of beta decay. So be very careful to understand that you're adding a proton. So this is also going to change, like alpha decay did, the identity of the atom. So the atom now becomes something else. So uranium becomes Th and He, as Cs becomes Ba, but here, because of the beta decay, it's actually going to gain a proton instead of lose them. Now we have electron capture, positron emission, and gamma decay. Electron capture is a type of radioactive decay when a core electron combines with a proton to form a neutron, the opposite of beta decay. So here we have Al. It's going to capture an electron. What happens is it becomes magnesium, because here it combines with a proton to form a neutron. So a proton is lost here because this electron is combining with a proton to form a neutron. And because it loses one, it's going to become 12. But the mass number stays the same because the electron and proton are just making a new neutron and losing one proton. Now, a positron emission is a type of radioactive decay when a proton breaks up into a positron, which has the same mass as an electron but is a positive charge. So a proton breaks into a positron, which is a positive charge, plus a neutron, which is neutral. So what happens is the proton we lose a proton, so our atomic number goes down by 1, but we gain a neutron, so our mass number stays the same, plus we're going to get a positron emission. So this is going to be E positive. This is going to be E positive. So that's what we call a positron. And lastly, we have gamma ray decay. Gamma decay is a type of radioactive decay when the nucleus of a high energy radioactive isotope releases energy. The atomic mass and numbers are unchanged. So here we see that this is happening, but we're going to add plus gamma. And usually you're going to see 0 and 0 or just gamma. This indicates that we're not changing 60 and we're not changing 28. It's still going to remain nickel, but it has released gamma radiation. So we call that gamma decay.